Alright guys, so still in page 120, and I'm going to try to do the problem number 23. So first let me graph what you have on your book and then I will get back to you. Okay guys, so we're having a function f of x right here, and we know that this function f of x is equal to x squared, and we're trying to find the expression of the function g of x in green right here. So right away, what I can say is what? I'm going to try to use different color to go up to the point where I'm able to graph the green one. So first of all, I can clearly see that in both cases I have a parabola. One is positive, f of x, one is negative, g of x. Alright, so that means that at some point I will have a reflection regarding the x-axis, and the x-axis is right here. So I can expect that g of x is going to be equal to minus something, and this something is going to be square, as it needs to look like a parabola, and I need to have an x inside, right? Because I need to have this looking like a parabola. Now, if it was negative x squared, and just imagine that we are just dealing with a function h of x, and this function h of x right here, well, it's not very well done, so let me represent that much better like that. That would be h of x equal negative x squared, okay? And the negative meaning reflection regarding the x-axis. But now I've reflected. What I want to do is I want to move this function h of x to the right. And if I want to move, and if I want to have a shift to the right, that means the new function, let's call the new function d of x or c of x. The new function c of x needs to satisfy, so c of x needs to satisfy a shift of h of x to the right. And that means that, and I need to move that at least 5 units. So what I'm looking for right now is to graph c of x right now. And this c of x is basically equal to h of x minus 5. And that means I have a shift of 5 units to the right of h of x. Okay? And now, when I look regarding h of x, c of x, and g of x, I see clearly that g of x, and by the way, I need to have a square right here. Now I can see clearly that c of x has been shifting down of 2 units, okay? Because they are telling me on your graph that this point has a coordinate 5 for x and negative 2 for y. So that means that g of x is going to be negative x minus 5 minus 2. I can completely do the same thing for the problem number 26. So let's try to do the problem number 26. All right, so in this problem number 26, let me, if you don't mind, first represent what you have for the problem number 26, and then I will be back to you. All right, guys, so I'm ready to go. And so now what we are looking at is the problem number 26, and we have the function f of x, which is the cubic root of x, and we want to go up to g of x and find the expression of g of x. So first of all, I can see that my function f of x and g of x have a reflection regarding the x-axis. How can I see that? Well, let's first of all mark my x-axis and my y-axis. And let's imagine that I decide to do a reflection of my function f of x. And if I decide to do a reflection of my function f of x, that means this point right here is going to be right there. The origin doesn't change. This point right here is going to be somewhere right there. And so mainly what is happening is that I end up to have something like this. There we go. So right here, let's call that the function h of x. And this function h of x is equal to negative the cubic root of x. Negative means a reflection regarding the x-axis. Now I can clearly see that if I want, and you will excuse if it's not exactly a little bit more straight right here. Well, basically, if now I want to move from h of x equal g of x, I can see that I have a shift to the right. And if I have a shift to the right, that means that a new function, g of x, is a shift to the right of h of x of 2 units. So that means that basically I'm dealing with a g of x equal h of x minus, because I'm going to the right, 2. And so that means g of x is going to be minus the cubic root, and instead to have x, I'm dealing with x minus 2. Okay? Now, because I am dealing with a negative cubic root, I know that the cubic root of, by example, negative 2, it's equal to negative cubic root of 2. Why? Because we are dealing with the cubic root of negative 1 multiplied by the cubic root of 2, and the cubic root of negative 1, it's minus cubic root of 2. Therefore, I can also express g of x as the cubic root of minus x minus 2, which is the cubic root of negative x plus 2. All right? Just to make sure that we do understand that I can have the negative in front of my cube root, going back inside my my cubic root, and therefore in my problem right here, that means I end up to change all the symbol inside my parentheses. All right, so now let's try to do the problem number 52. On this problem number 52, we need to represent the graph of f of x equal minus x cubed plus 1. Right away, I can clear off the fact that negative x cubed, it's negative x cubed plus 1. Therefore, negative x cubed plus 1 this way. So, right away, what I can clearly see is I have a minus of a function g of x, plus 1, g of x being equal to x cubed. So, right away, I can see this negative is going to give me a reflection. I need to realize a reflection regarding the x-axis, and the plus 1 correspond to a shift, a vertical shift, and this vertical shift is upward. Okay, so I am going to graph x cube. So basically x cube, it is a function who looks like something like this. And then I want to do a reflection. So this is g of x. This is g of x with the y-axis right here and the x-axis right there. If I want to represent the reflection, I'm going to end up to have something like this. Oops, I'm going to change my color and put it in orange. All right, so now we are dealing right here with negative g of x. And now if I want to have a vertical shift upward of +1 unit, if that is 1, I basically end up to have something like that. And this is f of x, which is negative x cubed +1. Okay? Last one, number 40. So on number 40, problem number 40, we're having a f of x equal 1/2 of x plus 2 square. Because we're having the x plus 2 square right here, the plus 2 is inside the parenthesis. I cannot pull out this, I cannot have the plus 2 far away from my x. It has to be next to the x because it's inside my parenthesis. That makes me think about a vertical, horizontal shift. And because it's a plus 2, it will be to the left. And then we are dealing with a 1/2 in the front, and that is a shrink. That is a shrink, vertical shrink actually. It's a vertical shrink, and it's a vertical shrink because c is in between 0 and 1. Okay, we are dealing with a coefficient c which is less than 1. So if I want to represent that, I am going to first represent x squared. That is the function x squared. Then if I want to represent the x plus 2 square, which is an horizontal shift to the left of 2 units, let me use my green. If that is 1 unit, that is 2 units. And then end up to have right here the function x plus 2 square. But because now I need to have a vertical shrink, I am going to get something like this, and this is the function f of x. All right, guys, so I hope that I cover a few questions you may have. I will try to go over maybe in another video about the question of the domain and the range. So stay tuned.